Returning to our digital tracker, remember that we were still left with the problem of busy waiting, where we're wasting CPU cycles just waiting for another thread to change the value of a variable. We're going to solve this problem by creating a conditional wait variable. So the code will look like this. Instead of having a while loop on whether the condition is met that does nothing, the while loop now makes a call to cond wait. CPU cycle saved. The second thing to notice is that the mutex variable is back, and it gets passed in along with the conditional wait variable into the cond wait procedure. We do this because we want to make sure that the condition in this while loop still holds when we put the thread onto the wait variable queue. The nightmare scenario is that in between this check and the call to cond wait, another thread changes the condition and sends the signal. Then we could be waiting for a signal that might never come. So it's good practice to lock variables that might cause the condition to change before you make the cond wait call. The cond wait method itself puts the active thread on a waiting queue and then unlocks the mutex so that another thread can change the condition we are waiting on. When the conditional signal comes, the method then reacquires the locks before returning. That's why we need to unlock it again down here. Now, somewhat surprisingly, we need to recheck our waiting predicate, that is buffAvail equal to 0, again before moving on. That's why we have the while statement here instead of an if. The reason for this is that we might not have been the first thread to acquire the lock. Another thread might have acquired it first and changed back the condition to something where we would need to wait again. In this digitizer example, I guess maybe that would be another tracker. Putting this in a while loop so that we recheck the predicate after the signal comes is called rechecking the predicate.